Can everyone see my screen?
Oh, yeah.
Excellent. All right, I've introduced myself, so I'll probably move on to the agenda that I'm going to be talking about today. So I'm going to be talking about the streaming platform that we use at Belong and some of the foundations or governance that we built along the way to make it a successful platform, and a use case towards the end on, I just picked one use case where I could think of really good things to talk about. And then we'll move to question and answers towards the end. All right. So at Belong, when we decided to bring in a streaming platform, we were evaluating between MSK and Confluent. But at that time, the process within Telstra is so complex. It was going to take us quite a lot of time to bring in Confluent. So that's why we said, let's go with AWS MSK, given that AWS is already approved. So there's no real reason as to why we didn't choose Confluent. So if Confluent was already a pre-approved tool, we would have gone with Confluent. But given that AWS MSK was a managed streaming platform for Kafka, we decided to go ahead with it. And the way we set it up was to have it as a highly available platform across multiple AZs and integrated with AWS ecosystem like IAM, CloudWatch for Alarms, etc. And then the benefits of going with a managed service was obviously reduced operational overhead, built-in security and compliance, and seamless integration with all the existing AWS services. Although when we started, there were less services that could seamlessly integrate, but now I think there's more integration, bit more integration with MSK. All right, so the next few slides are going to be some of the foundations or concerns that we want to address before the teams or the engineers started adopting the platform. So we wanted our cluster to be secure. We wanted to have some standards when we actually contributed. So you see a few slides talking about that. So firstly, we wanted to ensure that everyone that can communicate with a cluster are authenticated and authorized. And MSK cluster provided us with a bunch of options. At that time, when we chose the platform, SASL Scram was the recommended way to go. And SASL Scram is nothing but username or, salted hash, where we use username and password via the SASL framework. And when you create, so username is nothing but the principal that you use when you perform RBAC on the resources within the cluster. And obviously password is for authentication, right? So when you create a username and password, you first create them in Secrets Manager. You associate that secret with the cluster, and then you move on to authorization, where you associate that principal with some ACLs to each topic or producer or consumer. So your producer can, a producer principal can only write to a topic, whereas a consumer principal can read from the topic, right? Or create a consumer group or describe consumer group. So we wanted to ensure that every producer and consumer authenticates with the cluster eventually, because the cluster will eventually store PII or sensitive information, right? So we don't want everyone to have a free pass of the cluster. And the important thing that we said was, yes, there are multiple options to configure the cluster, but we decided it has to be done through code. Like, because over time, when there are 100 like I wouldn't say 100, maybe even 40 engineers are contributing, like you don't want people to run random commands at your cluster, right? So we decided everything will be managed through code. So we chose Kafka plugin, Terraform Kafka plugin to manage all of the configuration for us, which means everything is managed declaratively, starting from authentication, authorization, and pipelines to actually configure our cluster. So this way, we were able to scale very easily across the organization. And if at all we lost the structure due to some crash, we would be able to restore all of our configuration. So it was a conscious choice. Moving on to the next thing. So once we secured the cluster, now the first thing we do is we create topics. Obviously, you can name the topics however you want, but we decided we want to have some sort of pattern that the teams actually use to define the topics. And what are the things, why did it matter? So one is discoverability. So we could have a clear ownership and purpose at a glance. And the next thing is to provide governance. So consistency and enforcing boundaries between events and operations, easy filtering, monitoring, and access control. So I'm just showing you a sample pattern or the pattern that we use. So we start with environment, followed by the type of event and the data set, and probably followed by the data name. So you can imagine what these different properties within the pattern are. So N could be dev, staging, prod. The event type could be an application event. I'll talk more about the event types later. The event type could be app, a CDC event, or a domain event, or an integration event. And the data set could be a CRM data set, or billing data set, or network. And the data name, for instance, within CRM could be about customer, or from billing, it could be about subscription, or for the network data set could be about outages. Right. So this way, we are able to easily locate our data and provides a convention that the teams could follow, especially when a team that emits the data and the team that consumes the data are completely different. This provides a clear structure or clear information about what the topic is all about, right? So I've also shared some examples here, like prod, a CDC. CDC basically change data capture. So for instance, let's say our CRM system is Salesforce. Anytime there's a change in customer attributes, that gets copied over to this topic, and then the data team pulls the data and pushes it to data lake, right? And that's how we manage our topic names. And then event architecture and data format. The next thing was, how do we manage different types of events within our systems? What was important was having a category of events and the data formats. It was very important for us to realize the events that we have control over versus the events that we don't have control over, and the data formats and the data formats that we want to use for different types of events. So we settled with 3 different events. There could be more. The first event is application event. So this is primarily consumed by internal applications. And the format we said was JSON. And these are events that we don't have any control over. For instance, this could be an event that's emitted by an IDP system or by Telstra or external vendors that we don't have any control over. So we said, we'll just store these events as it is in our topic. In this case, if we decided even maybe SQS would suffice. But given our eventing platform is Kafka, we said, if it's external integration, especially vendors, we'll store the events as it is in the format that they give us. So majority of the vendors today support JSON, so we decided we just store the format as it is. And then comes the domain events. So domain events are for events that are consumed within a domain where, let's say you have an order activation and order fulfillment, their order domain, and you want the orders emitted by order activation to be consumed by order fulfillment, then we consider that as a domain event. And then the topic name would have a prefix that says DOM, right? And then for anything that's domain or interdomain, we decided the format would be Avro because it's emitted by belong. And we want to have, the reason why we chose Avro was for us to have a schema evolution for teams within belong to be able to discover the schema and be able to consume the messages as well. And that's why we said we'll use Avro. And obviously it's in binary format, which means it'll take less space compared to JSON. In this case, the example that I gave you, if a domain wants to communicate within itself, like subdomains, etc., then we prefix the events with the event names with DOM, and also the topic name that says DOM in front of it. And then the integration events. So these events are cross-domain events. For instance, an order event that needs to be consumed by a billing event to do something in the billing system, right? So these are called integration events. So obviously these are cross-domain, like I said, order to billing. And then again, because these are events that are emitted by belong, we decided we'll go with Avro format because again, like I said, it provides schema evolution, discoverability for other teams to consume and use the events. And the key principle here was decreasing coupling as you move up the hierarchy and increasing the contract stability as you move up. So we ensure that we are backward compatible with all of our changes that we make to the schema. And the schema registry that we use also provides some sort of catalog on different on the schemas for people to discover and use. And given that we're using AWS MSK, obviously we can't use Confluence Avro Schema Registry. We use AWS Glue Schema Registry. All right. So we talked about three things: authentication, authorization. We talked about topic naming conventions, and we talked about event strategy and data formats. Next is, yes, how do I now? AWS does not provide any sort of tool to view what's inside the topic. There are two options. One is you buy a tool. The other one is use the CLI to do it, right? With the CLI, sometimes I feel I get lost in the ocean of options each and every commands have. So we made a conscious choice to buy a tool, and we use KPower. And these are the four reasons why we use KPower: real-time querying using Kafka or KPower JQ, KGQ. We are able to visualize the messages. We are able to replay messages in case of prediction issues. And given that our topics could have sensitive data, the PI masking feature within KPower helps us to mask sensitive fields. For instance, a mobile number, first name, last name, address, etc. And it's helped us quite a lot. Like it goes really well with the cybersecurity teams and risk team. They're like, yes, if you're able to mask PII, that's a tool that we actually want. And it kinds of prevents people from copying data as well, right? So this is our tool. Even a couple of days ago, we were using KPower to troubleshoot a production incident. It makes the whole journey of working with topics really easy, or the Kafka broker really easy. All right, let's talk about use case. So there are many use cases at Belong that we use SMS for. This was an interesting one. Probably in the next slide, you will know why. So we had a use case where we, us being a telco company, we wanted to send SMS for a variety of reasons. One is the SMS could be for OTPs, the SMS could be as a reminder for customers to pay their bills, or SMS could be about outages, or it could be some sort of marketing messages, right? So the OTPs are considered critical messages, and we did not use Kafka for that, but there are two categories of messages. One is the operational one, where you remind the customers to pay the bill, or the marketing ones where we say, hey, we've got new promos going on, right? So we decided, so the traffic was bursty. We want to build a solution that was resilient and fault tolerant, and that can adhere to downstream systems rate limits. So things that we considered, we wanted producers and consumers to evolve independently, and then we wanted resilience and reliability, where built-in retry mechanism is retry topics, and it provides durable storage and a guaranteed delivery. And then we can we also wanted data queues. We wanted to have rate limiting and prioritization, and the message ordering. Basically, when I send multiple messages to the same customer, it needs to be sequenced or ordered by that customer. And partitioning topics helps with that, right? So this was our setup. There was quite a few other components that were there as well, but we never got to build it. But this was our high-level setup. So we could be getting messages from a marketing cloud, from a CRM system, or from our IDP that goes into our notification service. And then there are two topics. Based on the message type, we would actually push it into two different topics. In this case, we call it app dot notifications dot SMS dash operational. You could see how the topic naming conventions coming into play. we stored it as JSON because notification service is an API which was already enforcing a contract. So all this consuming systems had to comply with that message structure. And based on the message type, we would push into respective topics, right? And then the notification service, and we had rate limits. Like I said, we had rate limits, right? So the notification service would pick up the messages. We had two different consumers, one for operational, other for marketing, because rate limits were different for different types of messages as well. So the notification service would call the token service to say, hey, do I have a token to send the message? If a token is available, it will call the SMS service and the message would be sent out. If the token wasn't available, it would do a exponential backoff with jitter and then request for the next cycle. It'll wait for some time and then it'll request for a token. So this was a very simple setup, and we never thought things would go wrong with this, but it did go wrong. So why did it go wrong? So in this case, our initial consumer configuration in production, like we also have high availability with our workloads. So we have a number of workloads that we were running were 3, and we were using Streams API to process the messages. So we configured number of stream threads to 2 per workloads, which meant we had 6 consumer threads. And each thread by default would pull in 500 messages. And this was default configuration. We didn't change it. And then the max poll interval, the time before which the consumer has to acknowledge that I've processed all the 500 messages was 5 minutes, and we didn't change that. And if the token wasn't available, we would retry after an exponential backoff with the jitter. And because the SMS service for different types of messages, it could only take 6 tokens per second, we configure the token service to fill the bucket with 6 tokens every second. So can anyone take a guess as to what could have gone wrong with this? And did you feel that this setup would work straight away in production? All right. So what happened?
I'll have a guess. Did you exceed your max poll interval?
Yes, the worst thing that could happen in fraud, especially with SMS messages. Yeah. So you can see my token service was only giving me 6 tokens per second. Why would I even fetch 500 messages in the first place? And then we kind of realized maybe Kafka wasn't even the right solution for this. But the Kafka was chosen as the platform because there was a much bigger architecture that we wanted to build, which never eventuated. But it hit us when we went to production. So there was 6 threads pulling in 500 messages, which was basically 6,000 messages. Sorry, 6,000? 6 times 5, yeah, 3,000 messages. And we know that we can only do 6 tokens per second. So straight away, the 7th message is going to call for a token within that a second, and then it's going to fail because there's no token, right? And then it's going to go into an exponential backoff. Imagine this happening across the remaining thousands of messages. And when you do an exponential backoff, you're blocking the thread basically, right? Which meant that we were not sending heartbeats back to the broker. The consumers were not sending heartbeats back to the broker. And the broker basically decided that the consumer thread was dead, which meant it replayed the messages. So what can go wrong with replaying messages here? Customer receiving multiple messages, which does not play really well, right? So whenever you're designing solutions, make sure you always check the defaults for the problems that you're trying to solve. Like sometimes you cut, paste, copy from a previous solution, which may have been right for the previous solution, but not correct for the solution that you're designing for. So we immediately said, okay, we know we can only process 6 tokens per second. We're going to reduce the number of stream threads from 2 per workload to 1 per workload. And a number of messages pulled by each thread from 500 to probably 10, right? So that's the rate at which we can pump in the messages. Because this is a production incident, that was the immediate thing that we could think of. And then we made the change and everything just flowed through easily. And then reflecting back on how we could have solved it differently, then there are other ways you could have solved it as well. One is like if you used queues, you'd have similar problems as well. You would exceed the, what do you say? If you used SQS, you would exit the visibility timeout and eventually you'd be replaying the messages because it'll be visible for another consumer. Within Kafka, how would you solve this differently? So Kafka Streams provides another functionality called punctuators, right? That's another way you could have solved. Punctuators come online at specified intervals. They read only they read X number of messages you specify, and then they call the SMS service, right? That's another way you could have solved, but that comes with its own complexity because now the punctuator needs to manage state, which meant that you need to use RocksDB to manage the state, which means your workloads need to be stateful now. So the complexity increased in another area. So we said instead of designing stateful workloads, we'll just go with this configuration because we know it's working and we decided to actually stay with this. And an important lesson for this after this incident was always revisit the defaults, ensure that ensure either the defaults work for your solution. If not, if you need to apply back pressure, make sure that you tune your configuration and you tune your based on the limits of your downstream system. And we haven't had a single incident after changing this configuration. Any questions on this use case or the lessons we learned? All right. So we felt when starting on a journey or when you're already on the journey, it is very important to ensure that the platform foundations and governance are strong, which in turn enables engineers to contribute efficiently and confidently. Like I don't have to worry about people going and configuring cluster directly because we've locked down the cluster. And if there's an incident tomorrow, we know how to reproduce an incident. We've secured our cluster and we have a catalog of all the schemas that we use for the consumers, which enables teams to talk to each other using the schema. Or understand the data formats, etc. So spend time with your teams trying to understand what they're trying to achieve from the platform and how they wish to use the platform, etc. So it's very important to get it right because if you don't get it right, trying to do it at a later point of time is very expensive. All right, that's me.
All right, yeah, let's open up for questions. Derek, hand up straight away. Derek, if you'd like to come off mute and ask a question.
Yeah, sure will. And just firstly to say, Nagaraj, thank you so much for sharing that experience. I love a good real world use case of Kafka, and like SMS messages is about as real as it gets. And when you asked who could see the problem in the config, I was looking at it real hard and I couldn't think of anything. And it's great to talk about real world things where, double playing SMS messages to end customers is something we can all imagine. I don't work in telecoms, but I can imagine that probably caused some consternation at the time. I had a couple of questions really. One of them is sort of related to that. You tell the story of growing the experience around the implementation, and then you mentioned that since you changed that configuration, that you haven't had any production issues of that type since. Have you found it hard to kind of grow and retain that familiarity with Kafka in the team at Belong? Is that something that, from a team perspective, because it's almost like knowing the magic numbers and the magic things when you bring new people into the team, they're not. How do you stop them from making those mistakes again? How do you share that information?
So we have PARs. PARs is one way to post-incident reviews, one way to share. And we have Chapter Connect, like different practices have different Chapter Connects. So we share our learnings in the Chapter Connect as well. But that knowledge is lost as people move in and out of those roles, right? AI has made it easy where you could create knowledge articles about issues you've passed, and you could query AI for why a configuration was done a certain way, etc. It is very hard. Like, we haven't found a foolproof way to retain that knowledge. It is only through these discussions we reinforce how important it is to not overlook the default configurations.
Yeah, that's really interesting. And actually, that was going to be my follow-up question, was actually about AI, which is more of a general one, really. But I'm sort of interested to know how do you have AI on your radar at the moment in terms of a tool that you would use with Kafka data, like beyond the sort of the knowledge base and getting some answers about configuration and so on for your team? Do you see yourself as a team at Belong being one that would be comfortable with AI doing operational stuff with Kafka data and making realizations about things that are flowing around the business? Is that on your radar?
It's not on our radar. And we've thought along the once the data reaches the data lake, how we'd use AI to get insights, because that's where we join all the data and we are able to create insights, but not within Kafka, because not every journey is connected inside Kafka. But what would definitely help is help the developers is like if it could provide, like if you're able to provide your use case and if it could tell what sort of configuration you use and what you need to think about in performing in solving this problem, that would be super useful. I don't think we are in a level where we could give it off. We could give it to stakeholders and derive insights from the data that's stored right now. We're not there yet. But we're constantly looking for opportunities on where we could embed AI and realize value.
Thanks. Yeah, I think that's when I'm having conversations with engineers in the field. It's pretty common, and it's always interesting to get another reflection of that, because that story is sometimes quite different to. It feels like everything is AI everywhere all of the time now, maybe. So, yeah. Thanks, Nagaraj.